Yeah, good evening all. So myself, I'm Vijay. So I hold 70 plus years of experience, which includes 8 plus years of experience in Hadoop and Spark environment. So before I start, can anyone please confirm whether my voice is clear, whether the screen is visible or not?
Yes, sir.
And sorry for the delay, I had some connection problem. Right. Fine. Spark. So first, like evolution of Spark, right? So Spark was developed by Meta-Zaharia, right? The personality who developed Spark, but developed by Meta-Zaharia in AMP lab. In AMP lab. Berkeley. Spark was developed by AMP by Meta-Zaharia in AMP lab Berkeley in the year 2009, right? It was open sourced. It was open sourced in the year 2010. It was open source in the year 2010. It was Spark was donated. Apache Software Foundation, right? Apache Software Foundation in the year 2013, right? So it was developed by Meta-Zaharia in AMP Lab Berkeley, and it was open sourced in the year 2010, and it was donated to Apache Software Foundation in the year 2013, right? Yes, Spark. I can define Spark in 5 lines, right? Spark is a okay. Spark is a right. Spark is a distributed execution framework. It's a distributed execution framework in parallel process style. Distributed execution framework in parallel process style. With in-memory computing feature. In-memory computing feature. Distributed execution framework in parallel process style with in-memory computing feature used for large-scale data processing, right? Okay, you can see if we compare this with Hadoop, right? Hadoop is distributed execution parallel process for large scale data processing, but in-memory computation, you are not going to see in-memory computation, right? Distributed execution framework in parallel process style with in-memory computing used for large scale data processing. In-memory computation means in Spark, Data gets stored within the RAM, data gets processed within the RAM. So it gets stored within the RAM, data gets stored within the RAM, data gets processed within the RAM. In memory computation, that memory level storage and memory level processing means within the RAM level storage and RAM level processing. That's why we see very high speed for Spark as compared with the other technologies, right? Yes. Spark Spark can run on what, like Yarn, Hadoop Yarn, right? AWS, Mesos. Spark can run on distributed frameworks, right? Like Hadoop Yarn, AWS, Mesos. Okay. Spark can be coded with means Spark is an execution model. So we can code Spark can be coded in multiple languages. Spark can be coded with SCALA, Python, Java, or language. So multi-language support. I can select multi-language support or language. It can be coded with SCALA, Python, Java, or language. Spark by default written in SCALA. Spark by default written in SCALA, right? Yes. So Spark by default written in SCALA language. By default, SCALA is the native language of Spark. If you see that execution generations, right? If you see the various execution generations. MapReduce, we got right. MapReduce. Tej. Spark. Observe here, MapReduce, Tej, Spark. So MapReduce, previously we have got a great boom for MapReduce, but it's totally got outdated as of now. It's a parallel processing. It is designed for parallel processing, but now when Spark was introduced, right? When Spark came into the market, the usage of MapReduce has reduced a lot, right? Tej and Spark. Observe, if I can, Tej versus Tej and Spark. If I just compare this Tej and Spark, right? Both uses DAG model, directed acyclic graph. Both DAG model, right? Both uses DAG model, directed acyclic graph. But the advantage of Spark over Tej, right? Spark uses directed acyclic graph DAG with in-memory computation, in-memory computing. So what is missing in Tej is in-memory computation, right? We see very high speed in Spark. As compared with Tej. Spark has very high speed. Spark has very high speed, right? Yes. Not only, what are the other in-memory computation technologies in the market, right? What are the other in-memory computation technologies, right? Yes. Other in-memory computing. Other in-memory computing systems. SAP HANA, right? SAP HANA. Right. Spark and HANA. Comparing Spark and HANA, right? Yes. Both are in-memory computing systems. Both are in-memory computing. But what is the advantage of Spark over HANA? What is the advantage of Spark? Yes, yes. So yes, the prerequisites for this Spark, right? So so everything like basic Linux, those basic Linux commands, basic SQL knowledge, even basics of HDFS, right? Hadoop distributed file system. This Hadoop distributed file systems, not a problem. This basics of HDFS, I can provide you the videos of this basics of Linux, basics of HDFS. You can go through, just not a bigger thing. All one line commands we see for HDFS and for Linux. Okay. Yarn architecture. So here anyhow, this is I'm going to discuss as part of this course, right? Yarn, yet another resource negotiator. I'll be discussing about the entire how the processing is going to happen, the processing architecture, yet another resource negotiator. This everything I'll be discussing in brief. Yarn and yarn components, how this is going to happen. These things. Basic Linux, basic SQL, basics of HDFS, right? Yes. Fine. Yeah, total SCALA I'll be discussing, right? Total SCALA programming I'll be discussing for nearly 15 days, right? I'll be discussing on SCALA before I go with actual Spark, right? So nearly I'll be spending 60 to 70 hours, right? For this 60 hours, right? Totally for 60 hours for this entire course, 60 to 70 hours I'll be spending. In that, it includes nearly I'll be spending 15 to 20 hours on SCALA programming. Nearly 15 to 20 hours on SCALA programming, right? Yes. Yeah, so as for the general queries, I'll be giving time at the end of that, right? Fine. So Spark and HANA both are in-memory computing, right? Both are in-memory computing systems, right? Fine. But what is the advantage of Spark over HANA is HANA is not distributed.
Yeah, Vijay, what is HANA?
SAP, right? We have got other in-memory computing systems, means in SAP HANA is there. So it is also a in-memory computing system, SAP. Fine, it's a component within this SAP, right? Both are in-memory computing, but HANA is not distributed. So I'm talking about what are the other in-memory, not only Spark. Is there any in-memory computing systems available in the market? Means in SAP, we can see HANA is there, which is got in-memory computing, right? But HANA is not distributed, right? Spark is distributed RAM. Distributed RAM means your data object is going to be divided into multiple partitions. The partitions are going to get distributed across multiple RAMs of multiple worker nodes, right? Slave nodes. So here the data object divided into multiple partitions. The partitions distributed across multiple RAMs of multiple slaves and are processed parallelly. That's the thing we see, very high speed. In Hadoop, if we talk like data storing within the disk, here within that Spark, data getting stored within the RAM level, right? So RAM level storage and processing will be much faster as compared with disk level, right? So very high speed you can see in Spark, right? As compared with even Hadoop, right? Fine. Observe. So motivation towards Spark. Mainly, first thing, in-memory computation. In-memory computation, right? Second, distributed execution. Parallel processing. So if you see this, Apache Kafka is a streaming and messaging system. Yes, Narendra already. So it's Apache Kafka. Kafka is a streaming component. It's a streaming and messaging component, right? Advanced streaming and message for capturing live streaming data. We go for Kafka for streaming and messaging also, right? Establishing connections between different distributed applications, right? We go for Kafka, and also for capturing live streams, we go for Kafka, right? So here also I'll be discussing within the Spark. I will be discussing about the streaming, right? So here within the Spark, it is for micro batching. In Spark, I want very quick updates. For every 10 seconds, I want updates. For every 20 seconds, I want updates, right? So here we have got a Spark streaming available. Spark streaming means like micro batching, we say, right? Micro batching means very for every 10 seconds or every 20 seconds, I want to keep on updates, right? For that batch and micro batch. Hadoop or Spark for batch processing, we say, but micro batch means for very within the 10 seconds or 20 seconds, how many events generated that need to be processed, and I want quick results, right? Fine. See, actually, observe this. So events are for example, see, observe this at one side. So at one side, events are generated at a very high speed. At the other end, in the same speed, the events need to be processed. At the same speed, the event need to be processed, right? So this technologies like Spark can process it at a very high speed, right? So Spark is a kind of technology which can process the data at a very high speed, right? So at capturing at one time, capturing the events and processing at the other side, right? At one side, capturing at the other side. Let's Spark streaming, I'll be discussing it right as part of this. But motivation towards Spark, mainly like in-memory computation, distributed execution. Data object is going to get divided into smaller partitions, distributed across multiple memory RAMs of multiple machines, right? Okay. So generally, like observe this. For unlimited data storage and processing, for unlimited data storage, see, Spark is a processing technology, right? It's a processing model, not for storage. Spark is not for any storage, right? It is not going to store anything, only for processing. Just like if we talk about in Hadoop, we got like a big hive, right? In the same way, Spark is same like processing is meant for processing. So for huge storage, Hadoop. For huge data storage, Hadoop HDFS. For fast processing, right? Spark. So combinedly both can store and process it at a very high speed, right? Yes. For huge data storage and for fast processing, you can say like Hadoop and Spark. Okay. Previously, okay. SAN, previously we have got SAN. Previously we have storage area networks, right? SAN. They can also store unlimited data. They can also store like unlimited data, but cannot process, they cannot process, right? Okay, fine. 1 second, just give me a second, right? Yeah, sorry. Yes. Previously we had storage area, they can store unlimited data, but they cannot process the data, right? Yes. Spark is mainly designed for batch applications. See, batch applications, online applications, right? Hadoop or Spark is not for online applications, not for online processing. Therefore, batch applications. Batch applications, and what is the difference between batch applications and online applications? Means online applications, user interactive, user gives the input. For example, performing any online transaction or booking a movie ticket or anything, like we require user gives the input there. Batch application, user non-interactive application where user is no way required, right? So most of these finance applications, right? So they are background applications, they are batch applications, right, which runs in the background. For example, if you see the millions or trillions of records, right? Means if example of batch application, right? Credit card, for example, credit card bill statement generation for millions of customers. User involvement is nowhere required, right? User doesn't give any input. Bank statement generation for millions of customers. Phone bill statement, right, for millions of customers. For all this, these are batch up where user is nowhere required, right? For example, railway ticketing PNR status. means the status of your waiting state is 200, or slowly after 2 hours it becomes 150, becomes 100, slowly after one day totally your ticket gets confirmed. Here it's a user is nowhere required, right? User involvement is nowhere required. This is what runs in the background. So these are only for batch applications. Spark is mainly designed for batch applications. But if you want go for online applications, batch plus online, if you want, right? So integration, like you will see, like integration, right? Spark integration, Hadoop and Spark integration with the NoSQL databases. NoSQL databases can perform online processing, online applications, right? So today, like NoSQL databases has got a great boom. So schema-less behavior, random access. The next generation databases we say like NoSQL databases. So most of the top 50, the sites top 50, right? So the sites using NoSQL databases. E-commerce sites, I mean, right? E-commerce sites. Iterative algorithms, right? So Spark is mainly designed for batch applications, iterative algorithms. Iterative algorithms means, see, Spark, the advantage of Spark. So if you heard like great boom for Spark, one is very high speed processing. One more main advantage of Spark is Spark supports library like machine learning library, right? Spark supports machine learning libraries, MLlib. There is a library, MLlib, machine learning library also supports, right? Initial version Spark was very weaker in this machine learning, but slowly, right, in the versions from 1.6 and 2 version onwards, right? Spark has become very powerful even in this machine learning libraries. And for it, because these ML algorithms, most of these algorithms are iterative algorithms and interactive queries. Interactive queries. So we can query the data using Spark. We have got a Spark component, Spark SQL, right? We have got SQL context, right? Where we can perform querying. Normal SQL queries can be done, where we make the data structured, like we use data frames. On the data frames, we have got many data frame APIs available later. Like if you want to work with pure SQL statements, also converting the data frame to temporary tables, and on that we can perform querying, right? And streaming, Spark is streaming, right? Streaming, micro batching, and for graph algorithms. The graph algorithms, right? Yes. Motivation towards Spark: in-memory, distributed execution, parallel processing, high speed, very high speed processing, very high speed processing. So I was saying an example while discussing Hadoop, right? Hadoop comparison with other databases, right? I was saying an example. Yahoo has taken a table to test the speed of various databases, right? Yahoo has taken a table of size 100 TB consisting of 1024 columns. Yahoo has taken a table of 100 TB consisting of 1024 columns. The task was sorting, right? The task was sorting based on 16 columns. Time taken by various databases. Time taken by various databases. Oracle. It has taken nearly 3.5 days to process it, right? MySQL. It has taken nearly 6 days. Teradata, a specialized database used for data warehouse purpose, right? Teradata, it can handle TBs of data, and it has just taken 4.5 hours, right, for to process it. And Netija, another specialized database. Netija, right, another specialized database, it has just taken 3 hours. 3 hours, right, to process it. Okay. Finally, Hadoop. Hadoop has just taken 3.4 minutes to process it. 3.4 minutes. The latest version of Hadoop has taken just 1.2 minutes, right? Right. Okay, that's fine, Hadoop. But Spark is so I'm saying motivation towards Spark, very high speed processing. Spark is 100 times faster. Spark is 100 times faster than Hadoop. In memory. Spark is 10 times faster. In disk. If you see that processing, Spark is 100 times faster than 10 times faster in the case of disk. Yes, that is what the speed of Spark. So, and what is that other advantage we see with Spark is multi-language support. Spark can be coded with multiple languages like SCALA, Python, Java, or language, right? And what are the other things we see, right? Supports advanced analytics. It supports advanced analytics. After processing, if you want to apply any techniques, right? ML techniques, advanced to support some machine learning, streaming, SQL queries, graph algorithms, right? It supports advanced analytics. Okay. So in the earlier stages of Spark, right? If you to go back like in 2006, in 2016 or 17. So there was a talk, right? Spark versus Flink. Spark versus Flink, right? Yes. Flink. So in 2017-18, if you observe, right, there was a talk that Spark is going away from the market as Flink is dominating Spark. Flink was dominated. Yes, there was a talk, right? The Flink dominated Spark in the initial stages. So Flink, both are Spark and Flink, both are from Apache family. Both are from Apache family, right? Yes. Both are introduced by Apache, right? Both purpose. Objective are same. Both purpose and objective are same. In the initial versions, right? In the initial versions. In the initial versions of Spark, Spark was weaker. Spark was weaker in terms of machine learning library. Spark was weaker in terms of machine learning library, right? See that the heart of data analytics is machine learning, right? But from Spark 1.6 version, Spark 1.6 version onwards, Spark 1.6 version onwards, right? It has got a powerful libraries. It has got a powerful libraries, right? For all the components, right? For all the components, machine learning, graph algorithms, and for all this. And from Spark 2.0 onwards, Spark 2 version onwards, Spark has dominated Flink. From Spark 2 version onwards, Spark dominated Flink. So in the initially, like Flink was dominating. So like if you talk like before Spark 1.6 version, I can say like Spark was weaker, right? Means immediately after introducing Spark, right? Even the Flink was introduced by Apache, where Flink was dominating Spark. But what happens immediately is from Spark 1.6, Spark was dominating. It has got powerful libraries where for machine learning, the other things, right? It was almost equal to Flink, but from Spark 2 version onwards, Spark dominated Flink. Now you're not able to see that Flink, right? You are not able to have this word. So Spark and Flink, Spark Tej, Spark HANA, right? Yes. And I was saying like Spark and Hadoop, Spark is 100 times faster, right? Okay. If you see that Spark and Spark Hadoop, right? Yes. Spark sorted 100 TB data using 206 nodes in 23 minutes. Spark sorted 100 TB data. See the nodes 100 TB data using 206 nodes in 23 minutes. Previous world record was 72 minutes set by Hadoop, right? Set by Hadoop MR cluster using 2100 nodes. So here it has taken, even though these many nodes, 2100 nodes it has used, it has taken 72 minutes, but Spark just in 23, just by using 206, 23 minutes it has taken, right? So observe this. Spark data objects, for example, Spark data objects divided into smaller partitions. They are divided into smaller partitions, right? each partition, for example, each partition is RAM1, each partition is going to store across multiple RAMs of multiple slave nodes, S1, S2, S3, S4, S5, right? So data is going to be distributed, right? And they're going to get processed. In Spark, one more thing what you can observe, right? One more thing. Data is going to be divided into partitions. That partitions are going to be stored across multiple RAMs of multiple slaves and processed parallelly, right? For example, a huge data objects got stored across multiple RAMs. Okay, but what if you've got, whenever you trigger another job, right? So another job related to another data set, right? What if divide into multiple partitions, right? So what if already the RAMs got filled? Will they accommodate this data sets? So RTD, RTD1, R1 means, see here, R1 is what? Okay. R1, see this R1, this is your data object, right? It is going to be distributed across multiple partitions of multiple RAMs. Once the processing is completed, right? Once the processing is completed, this output is taken as input by the next one. By the next one, this output is taken as input. On this, this is your data object. On this data object, you are applying some filtering operations, some filter operations. You got some, so like the 50 lakh records available. That 50 lakh records after filtering, right? You got some, the output you got is like 10 lakh. The 10 lakh, right? It's collected by this, and again it is going to store across multiple. This is going to store across multiple. So whenever it loads this, right, the previous everything is going to get removed. Means in Spark RTD we say resilient distributed data set. RDD we say, right? I'll just give that total knowledge in RTD in the tomorrow session. What exactly is an RTD? Data objects, Spark data objects, we call it as an RTD, or resilient distributed data set. So for example, RTD1 is there, right? It has got this output of this RTD as taken as input by the next RTD, right? RTD2. When RTD2 is loaded into the RAMs, when RTD2 is ready, RTD1 gets removed from the RAMs. RTD1 gets removed from the RAM. Now RTD2 is existing. From that RTD2, again, this output is taken as input by the next one, RTD3. Once it has collected that output, when it is stored and it's ready, right? This RTD2 partitions, everything is going to get removed. Whenever the next one is ready, the previous one gets removed. The previous one gets removed. Right? Yes. Once the total execution completed, the output is collected, and the final RTD also gets removed from the RAM. Now, what is in the RAM? Empty, right? Again, you can just trigger the next flow, next job, right? Again, it's going to start from RTD1 gets, means if each RTD is of very bigger size, right? All these 4 RTDs cannot fit into RAM at a time. RTDs cannot be loaded into RAM simultaneously. All these RTDs cannot fit into RAM, RTD by RTD. Once that second RTD ready, first one removed, third RTD ready, second one removed. Finally, total execution completed this RTD. Now, what is in the RAM? Nothing will be in the RAM, right? Yes. How this RTD processing is going to happen, how this Spark data objects are stored, the other things, right? I'll be discussing in the tomorrow session. So just today is an introductory session, right? What is Spark? What are the features, advantages you see Spark, right? Fine. It's faster than even Hadoop MR, right? Fine. So I'll be discussing, if you see the course content, right? 1 second. Spark with Scala, right? First Scala programming I'll be discussing. Before I go with this, first I'll be giving introduction for next 4 days, 5 days. I'll be discussing about Spark, how this Spark execution model, the architecture, everything I'll be discussing. And once I am done with that, before I go with the actual practical part, I'm going to discuss Scala programming, Scala basics, Scala data types, variable declarations, the typecasting, Scala expressions, Scala control structures, Scala collections, transformations over the collections, what is map, what is flat map, filter functions, eliminating nulls and blank spaces, generating new fields, Scala functions, Scala used in map, functions used in filter, Boolean functions, various other examples, right? Later I'll come back to the Spark core, right? And Spark RTD computation, how the RTDs are computed, operations on RTD actions and transformations, steps in RTD compute, RTD persistence and persistence options. What are the various persistence options? What is the difference between the persistence options? Okay, and Spark core computing, right? Spark core computing, fault tolerance model in Spark, different ways of creating RTDs. Some examples, right? Creating Spark objects from Scala objects, right? Increasing the number of partitions, aggregations over the structured data, groupings and aggregations, single groupings, single aggregations, groupings and aggregations, and reduce by key and group by key, process of group by key, reduce function, various inbuilt transformations, inbuilt functions, various actions and transformations one by one with many working examples, count by key, count by value, sort by key, zip, union, distinct, join, inner, partition, co-group, right? So next, coming to the Spark SQL, making the data structured, case classes, using functions, using map, data frames API, data sets API, RTDs versus data frame data sets, working with SQL statements, Spark Hive integration, Spark with MySQL integration, working with CSV JSON types, deployment modes, local mode, cluster mode, right? And Spark applications, stages, tasks, drivers and execution, Spark submission, how to submit Spark jobs, creating jars using Eclipse IDE. I'm going to show you. I'm going to show you on 2 IDs, Eclipse IDE and IntelliJ IDE, and the build tools like SBT build tool, Maven build tool, right? For launching Spark applications, and also knowledge on Spark and Cassandra, right? Yes. This is what I'll be discussing as this part of this Spark course, right? So like totally we'll be spending like 60 to 70 hours, like 2 months course, which includes Scala programming and Spark, right? Yes. So if you got any queries, you can go with your queries, right? Yes.
Hello, sir.
Yeah, go ahead with your query.
Sir, after completing this course, what is the job profile, sir?
So like Hadoop Spark developer, you can go, right? Data engineer, you can go, right?
How much experience we can put on resume, sir?
So what the level, whatever level I'm spending 60 to 70 hours. That's why I'm saying, right? So you can, whatever I'm discussing, like nearly a 4+ years of experience person, how much experience is going to gain, the same experience I'm going to provide you, right? It all depends on how you are going to practice, right?
Okay, sir.
Yeah.
So, I mean, are we covering any streaming concepts or just batch?
Yeah. I'm going to discuss that streaming, micro batching also. Apart from this, I'm going to give the knowledge on Spark streaming and Kafka also, right?
Oh, thank you.
Fine.
Hello, sir. In compare with Java, sir, how is the Spark with Scala, sir? Any ideas?
Yeah, I said Spark can be coded with multiple languages: Scala, Python, Java, or language. Java and R language is never preferred. Actually, no company is preferring R language. Java very rarely preferred by the companies. Companies like I can hear only one or two companies like Value Labs, but most of they are going with Scala and Python. Scala means your Spark execution model, Spark APIs, everything remains same. Only the programming part is going to change, right? See, for example, Spark, whatever Spark related, everything remains the same. But the programming part is implementation part is going to change, right? For example, take Java, if you take Scala, if you take Python, implementation, coding, Spark. In Java, you say like index equal to 10. In Scala, you say val x equal to 10. In Python, you will say x equal to 10. Means the programming way, it's going to change. Functions, how you define functions, how to define variables, the way you define that loops, statements, everything differs in programming. But Spark related things remain same. Whatever Spark related remains same in all the three. Spark related APIs, everything remains same, right? But only the programming part is going to change in Java, Scala, and Python, right? But I said Java is very rarely preferred, right? Scala is the native language. By default, Spark built by using Scala language. Now these days, Spark with Python also. Fine, you can implement Spark with Python also, right? Yes. Yes. But Java, very huge coding required. That's why most of them, they are not preferring Java. Scala, we won't see that much of coding, very less coding, right? Very less coding in Scala or in Python. Fine. Yes. Any other queries, right? So tomorrow also, everyone can attend the session. Same time at we'll start the session by 5:10, right? 5 o'clock. By 5:10, we'll start the session. Fine. Same time using the same link, right? Fine.
Sir, can we discuss any project, sir?
So,
Or any project, all right?
So at the end, I'll be discussing the entire flow, right? That right flow I'll be discussing at the end, right? One.
Will you be providing videos or?
So every session is video recorded, right? Even if you are absent because of some ill health or because of some office timings you are unable to attend, you'll be getting that every day you'll be getting the recorded video of that session, right?
Okay, sir.
Sir, classes 5:30 to 6 or 5:10?
So daily, it starts 5 to 6, right? It starts at 5:10 to 6:10. Okay. So 5 to 6 daily. This class timing is what? 5 to 6, right? So daily 1 hour.
Okay, but time it is updated 6 to 7.
Pardon?
But in website it is updated 6 to 7.
No. It's 5 to 6.
Okay, sir.
It's 5 to 6, right? Daily.
Sir, before teaching Spark, you need to cover all concept of Scala, right?
Yeah. Scala. So total Spark implemented using Scala language. You need to know that knowledge. You need to have command on this Scala, right? So for nearly, I'm saying that 15 to 20 days I'll be discussing on Scala.
Okay.
Yes. Spark with Scala. So 1/4 of the course duration I'll be spending with Scala. Fine. Okay, so if I'm done with the queries, if there are no other queries, right, I'll just sign off for today. Meet you tomorrow, same time. You can follow the same link, right, to see more on this part, right? And only one thing what I expect from you is that regularity and regular. Whatever we discuss every day, you can just explore it by changing that values, the other things, right? With it applying on different data sets, data objects, right? You can get that command on the subject, right? Yes. And one more, right? The sessions need to be interactive. Everyone need to keep responding, right? Whatever we are just seeing the Spark processing, right? So how that will be taking multiple examples and we'll be just going through that, right? So I want a response from you. Fine. Okay, so stopping here, we'll continue tomorrow. Fine. Thank you all for your time. Thank you.
Sir, you are teaching Spark with Python, PySpark?
So PySpark batch is going in the weekend, right? Already one PySpark batch is going in the weekend. It's almost 60% done. So one more one more PySpark batch will be starting, right, in the coming days. Those, if anybody wants to go for PySpark, right, it's a separate batch.
Okay, sir.
Okay.
Hello, sir. Sir,
Yes.
I have one query.
Yes.
I'm automation tester. How this course helpful for me in a professional perspective?
So today, if we talk like where huge data is, wherever you see, we can see like huge data, right?
Right, right.
Right. If you are expecting very quick results, right? Very quick results. So Spark is a kind of technology, even where it can process that streaming, where it can interactive queries. So very high speed, and it is going to give the results in a quick speed, right? So Spark has got great women as a career aspect. You can choose Spark, or even as a, if you see that the salaries of especially for this big data developers, right?
Mhm.
It's one and a half time more than the other. If any other technology, you can just compare the salary packages as compared. Even I'm talking about the salary packages, career aspect too. You can just compare the packages of this as compared with any other, right? You'll be having more. But the thing is, they'll be expecting the same command on that technology, right?
Mhm. Right.
Career aspect too, or if you see that salary packages will be more for this Spark. And the people who know Spark is very less, competition is very less, right? But it is not a kind of technology which looks very simple and easier, right? But if you learn it, if you get the command, definitely you have got better opportunities, lot of jobs for Hadoop and Spark. Very
Okay.
less people, very few people, like if you see like people who get knowledge on Spark, and that too with a good command, right? Yes.
Yeah, right. Okay, sir. Sir, Scala and Spark both are open source.
Yes. Yes, yes, yes.
Okay, we can practice
Yes, yes.
parallel.
Don't worry about the software. I'll be totally demonstrating about it.
Okay, okay. Thank you, sir.
Even I'll be showing you how to run these things within this distributions like Cloudera, these things.
Thank you, sir.
Okay.
Sir, one question.
Yeah.
There is a course full stack AI program, and one is the big data developer. That is for data engineer. So, what is the difference between two? I'm totally new in this both of the courses. So, which one is in demand?
See
The
one.
now?
See one thing. If you go for data scientist,
Mhm.
if you talk about the data scientist, right? A typical data scientist need to have the knowledge about these things. How do, if you know, if you go to that, if you go to the big, what is that, data science trainings, you see there will be a module, Spark also. It's one of the modules.
Right, right, right. I have
One
seen.
of them, I don't know like what is the how much level depth they'll be teaching
Right.
the Spark. But as of now, if you see in that companies, right, these data scientists are dependent on this data engineers. What is this total extracting and processing everything,
Okay.
that they are dependent on that. But in the coming days, even that is asked to be done by them, by their own, right? So they need to have the knowledge. Everyone need to have the knowledge about this Spark.
Okay.
Process,
Understood.
processing means everything that extracting, processing, everything happens. Then comes the data scientist, right? Means which type of algorithm and how to analyze it, everything of the, from the processed data and from the processed results.
Okay, understood. Thank you, sir.
Extracting the data from the different data sources and processing it as per the business logic. Once you get the result, from the results, just you are going to apply this ML techniques, right?
Mhm.
So this everything done by this data engineer work, right? But typical data scientist, right, need to have the knowledge about all this.
Okay, understood. Thank you, sir.
Yes, sir, we did require logical programming, sir, is like coding.
So it's in Scala, we won't see that huge codings. In Java, we see a lot of codings, right? But in Scala, we won't see that much of codings, right? Very simple. Means Spark has got many inbuilt APIs available. We don't need to write codings. Directly by applying those, we can get the results. Many are there. Actions and transformations are there. Inbuilt actions and transformations. Just by applying them, we will get the results.
Okay.
Okay, fine. So I'm stopping here. We'll continue tomorrow.
Thank you, sir.